So I'm creating a game, a retro game for MS-DOS. I don't think that that is supposed to happen. Okay, so we've fixed the error here, and this should be good to go now. Let's take a look. Okay, so my goal is to create a game that runs on MS-DOS systems and to keep it within 48 kilobytes of memory. That's pretty difficult to do, but the reason is that this could run completely in memory on even really old systems. So I'm trying to use techniques for programming and a small amount of memory and simple graphics in order to make this run on systems before 286 systems. So MS and PC-DOS systems that have a limited amount of memory and resources. Whether it gets run on those systems or not, I will run it on one of my own systems, but more than likely, if anybody played it, it would be played in DOS emulation on a much faster computer. But the exercise should still be a lot of fun. So I'm going to talk a little bit about the game first, and then I will talk about the memory limitations and how I would keep this into 48 kilobytes of memory. 48 kilobytes is a little bit of a, it's just 16 kilobytes less than 64 kilobytes, and so it's a little bit made up number, but I'm looking at, okay, 64 kilobytes worth of memory on a system, and then some of that's used, and really it's pretty arbitrary. Keeping it even under 100 or 200K would be really good for any system that you would probably run this on. But still, it's kind of a fun exercise to keep this within a small amount of memory, and I'll talk about how I'm going to do that. But first, the game. So it's a top-down view. This is some sort of a spaceship or something like that. Again, the final graphics, these aren't even really beginning graphics. I'm just kind of have this sandbox that I can play around with. So I'm just got a spaceship that's not animated in order to save on Sprite graphics. And we have background tiles. Now, these graphics here, most of these were actually tiles made in a pixel editor by my 5-year-old son, just to be able to kind of test things out with. The idea is that you have a top-down view of a ship, there are other enemy ships, and you're supposed to go around and collect some sort of item. Right now I'm calling them crystals, but they could be whatever. And you'll be able to find these by either x-raying buildings or blowing them up and finding these items while avoiding enemies. There's a little home base here on my main screen, and then there's also these portals that allow you to go from screen to screen like so. Okay, and there's kind of a counter that kind of keeps track of where you're at on the overall map. So you're actually moving entire screens worth of tiles at once. I actually really like this method of play, and the reason is that it's really kind of exciting. So if you're moving around and the map moves with you, at any given point in time, you're only going to reveal a small amount of the map that you haven't already seen. So what's on your screen as I move toward the edge of a map, what's on my screen will mainly be what's on my screen in the next moments or the next few movements of your spacecraft, and things will be slowly revealed. But if you move like this, where you kind of use these portals to move from screen to screen, you can kind of get a surprise every time you move from screen to screen. So I think that's a really neat way to navigate the map, and I've always liked that type of gameplay. This is especially exciting if you are using some sort of procedural generation to generate the map itself, the backgrounds, and enemy locations and things like that. So every time you go through a portal or whatever it's called here to a new area of the map, then everything would be new and you wouldn't necessarily know what you're going to see. The idea is that you'll go around and you'll collect what you need to collect while avoiding enemies / killing enemies, and then eventually you have to make your way back to the home base to deposit those. I'm not sure why. I don't have a story for that, but it's just kind of a type of game that I think I would like to play. likely a lot of the backgrounds and everything will be procedurally generated, so I don't have to store maps because those are going to take up space, as we're going to talk about here in a minute. I'm going to show how all the graphics need to be made in order to fit within the 48 kilobytes along with the code and so forth. Now, this is a game written in BASIC, and therefore it's written from scratch. You don't have an engine or anything like that, and it couldn't be created using an engine or something if I wanted to fit this in a small amount of space, like 48 kilobytes anyway. But also, there weren't any engines really for the systems that I want this to run on. 286s, 386s, and the like is kind of the goal systems, and maybe a little earlier than that. 486s, of course, as well. And everything takes, so my point of that is that everything takes a lot of code. For example, you'll notice you can actually see through this ship as it moves around. So this is not something that's inbuilt. I can't just use a transparent image or something like that to do that. This is actually a series of binary operations that allow me to make this particular image. So everything takes a lot of work. So to actually make this work, there's actually 3 stages. The first thing I have to do is, when I'm moving my ship here, is I have to make sure I always have the background stored before the ship moves over the background. So I'm storing the background, and then I have a mask image for the ship that actually I do a bitwise AND to the actual background image in order to denote which pixels are going to be background and I'm going to stay background, and which pixels will be the actual sprite ship itself. And then I actually mask the image over it with a white background, so that that image will then be transparent. Basically, what the background will remain where it is. And actually, if I were to stop my program here and go back and look at the code, you can see that the highlighted line here is where I'm actually putting down a background in order to erase the current image. And then if I go up a little bit here, this is where I'm actually, well, that's the initial drawing of the protagonist or the ship. If I come down a little bit, then here you see I'm actually getting the background after I've placed a background over it, and then my highlighted line here, I'm getting the background before I place a new sprite, and then I'm placing a mask with an AND bitwise operation, and I'm placing the actual sprite with an OR operation. In order to do all of this, I have to have all of these graphics in kind of a bitmap format. I'm using 4-bit color, so 16 color palette. So I only have 16 colors to work with, and so every pixel only takes 4 bits because of that. And so, and that's for a couple of reasons. One is that I want to be able to store this in a small amount of space. I want the graphics to store in a small amount of space, but also older systems that have like EGA displays, this would be compatible with them. I'm using a 320 by 200 resolution overall, so that this will be compatible with the older EGA, but it will also be VGA compatible as well. So that's the main reason, is the actual systems that it would run on, and then add the memory I'm using. Now I can't use just like bitmap images and things like that. I actually have to just have the binary data itself, and then I parse that binary data, load it into memory when I'm running the program. So that's the main idea behind this, and this is just kind of something I can mess around with as I create the graphics. If anybody has any good ideas for creating the graphics, what the graphics should look like, for gameplay for this style of game, that would be really cool. One of the things I'm thinking is that kind of as you get away from the home base further and further, you will be able to get the things you need more easily, but you're going to be very far away from the home base, so then your trek back to the home base, kind of your travel back, will be more difficult because you're going to have to go through a lot more enemies and things like that. So again, I really just created this kind of quickly, but you can see actually, if I go to the end of this here, let's see, okay, if I go all the way down to the end here, we're talking about almost 400 lines of code just to implement this current just kind of base system. So it does take a lot of code when you're writing these retro games, and I'm not even writing this in assembler or anything like that. which would take a lot more lines of code. Obviously, these lines of code have nothing to do with the final compiled lines of code. I mean, there's a correlation, but that's about it. I also want to point out, I'm showing this in QB64, which is a 64-bit version of QBasic for actually creating Windows applications. This is not what I'm actually writing this in. I'm writing it in QBasic 4.5. All right, so let's talk a little bit about the memory and how we're gonna try to keep the memory anyways under 48 kilobytes. So I'm talking about using 48 kilobytes of memory for the entire game. Now, that's about 48,000 bytes, and I'm gonna be using this approximation for the whole time. Now, I'm gonna assume I actually need 32 kilobytes of memory for the code. So that's the code and all the variables and their values, not counting the arrays that hold the binary data for the graphics, but rather all of the code and all of the variables in the stack and so forth that I need. Now that may seem like a lot of it, and it is, because that's about 32,000 bytes, leaving me with a simple subtraction with only 16,000 bytes or 16 kilobytes remaining for graphics. And that isn't very much. But I actually think that's a good estimation of about how much I'm going to need. If I'm going to have any functionality in the game at all, it's going to take a decent amount of code. Remember, I'm coding everything from scratch. Not that using an engine would create a smaller final memory footprint for the code, because you would be using so many inbuilt functions and things like that actually have to be in your final code. So, no matter what you're doing, you're going to be using a similar amount. But I'm going to assume 32 kilobytes, which only gives me 16 kilobytes for the graphics. And that's not very much. Let's look at why. So here's my screen. Okay. Now on my screen, I'm going to have the background. And the background, the only way to really make this fit in a small amount of memory and also be changeable is to use tiles. Okay, so it's essentially going to be a tiled system, and it's just basically going to be a big grid of pre-made images that I can tile in different places to make different screens. So for example, tiles for grass, tiles for stone, tiles for different textures, and things like this. And then on top of those, I'm going to have sprites, okay? And so this is like my ships and anything that's gonna move. And so those take up graphics space as well, and they actually take up extra space because for every one of my sprites, I have to have a mask that goes with that sprite. And these are not sprites that I can control separately. Okay, these aren't built into the system like movable sprites that I can just move separate from the background, okay? These are simply graphics that I'm going to be placing and blending with the background to make it look like they're movable objects, but they're really just graphics just like the background tiles. So now, given that we have this set of tiles, how many tiles can we actually have and how large can those tiles be and still fit this in 16 kilobytes of memory? Well, let's do some calculations here. The screen resolution is 320 by 200. So I'm going to go ahead and use that as my background area, even though it'll be a little smaller than that, because I will have some menus around it that won't change, and I'm actually creating those through code, and I'm not actually bringing in graphics for that I'm storing. And so it will be a little bit smaller, but we'll just use the 320 by 200 resolution as kind of our base. Now, if you did some quick math here, 320 by 200, right? So that's actually going to be 64,000 pixels on the screen. Now 64,000 pixels at 4 bits per pixel, being that there's 8 bits in a byte, right? Actually gives us 32 kilobytes of memory just to store the pixels for the background. So obviously you can't even store one background if you were to just store it as one image, which is why we need to use the tiles. So that means we know right off the bat that to get 16 kilobytes worth of tiles, we would only be able to have enough tiles to cover half of the screen, and then we would have to reuse from there. But obviously we can't use all 16 kilobytes for that because we have sprites and other things as well. So what are we going to do about that? Well, we won't have that many tiles, and that's okay. Let's see what kind of tiles we could have at what resolutions to fit within a fraction of the 16 kilobytes that we have available. So let's say we want to use a 20 by 20 tile size. 20 by 20 is 400 pixels at 4 bits per pixel, right? So you can divide by 2 and actually get 200 bytes for a 20 by 20 tile size. 20 by 20 pixels for a tile gives us 200 bytes. So that's about 1/5 of a kilobyte. So per kilobyte we can get 5 of those tiles. So let's say we wanted to use 8 kilobytes to store our background tiles. Multiply that times 5 tiles and we could have 40 tiles. Now you could create backgrounds out of that and that would be just fine. And honestly, especially if we're procedurally generating things, I don't know that we would want a lot more than that, but you can get a lot more than that if you shrink the tile size. So if I were to shrink the tile size to 10 by 10, let's say, then that's actually going to be, 100 pixels, and that's only going to be 50 bytes, which means we could get 4 times the number of background tiles, or approximately 160 tiles in the 10 by 10 format, and that would still fit into the 8 kilobytes of memory. And that makes sense because if you had a 20 by 20 tile and you split it into 4 sections, each of those 4 sections would be 10 by 10. So all of this is just very, very simple. It's just a big grid, right? And every pixel in that grid takes up 4 bits or half of a byte. So basically, however many pixels we're gonna have half that many bytes of memory to store whatever image is in that area. So we need to store these tiles, but we only have to store 1 for each tile. So if we had 160 tiles, that would be quite a few, especially when you consider if you take let's do one more line here. If you take a background that's 320 by 200 in resolution, right? We know that is 64,000 pixels, and that's a lot of pixels. But if you divide each of these by 10, you get 32 by 20, right? And that means we only need 640 tiles to fill the screen. Divided by 160 equals 4, which means we would only have to use every tile 4 times each to fill the screen. So that would actually give us quite a few options. So the 10 by 10 tile size gives us a lot of options, which is really cool. And you could, for example, split a 20 by 20, let's say you got a really good 20 by 20 tile, you could split that into 4 10 by 10 tiles, and you could still do it that way, but you could place those tiles in different arrangements, or you could make your 10 by 10 tiles from scratch, which would probably be the better way to do it. And you get a lot more options and you can arrange a lot more complex environments, but here's the problem. I've talked about procedural generation of the backgrounds. That means, in a nutshell, I'm doing kind of a pseudo-random placement of things. I'm gonna randomly place the tiles, but with some sort of algorithm. And that's part of the reason that I think we need so much memory for the code, is we have to have an algorithm that places the background tiles. But it can't just be completely random. It has to be slightly smart in order to make the backgrounds look good. With the 10 by 10 tile size, you are essentially forced to use procedural generation like that. You wouldn't be able to make the backgrounds manually and arrange the tiles. Because the problem is, if you manually arrange tiles, let's look. I have a background here. Ooh, bad line. And I was to say, place this tile of grass here, place this tile of stone here, right, and so forth. I have to remember where those tiles go, and that means I need an actual map stored of the tiles in order to create that background. Well, the problem with that is that that takes up space. As we've mentioned, a single background would have about 640 10 by 10 tiles. Okay, well, you would have to then store which of those tiles are going to be placed rather in each of the tile spots. So if you have 640 tiles that you have to place, that's a lot, because let's say we have 160 background tiles, right? And we can do a log of this and figure out how many bits we need. But basically, more or less, we need 8 bits, right? We're going to need 8 bits to differentiate, to say which of those 160 tiles we want to place. That means 8 bits or 1 byte per tile in that background. So essentially 640 bytes are required to store a single map for a single screen. Now we'd like to have hundreds of screens so that you can move very far away from the home base and have a lot of good gameplay going on and a lot of different areas to explore. And that just wouldn't be a possibility, because you're well on your way to a kilobyte just for a single screen, so you couldn't do that. Now, if you were to use 20 by 20 tiles, let's say, we already know that that is 1/4 of the number of tiles, or only 40 tiles. So we'd only have 40 tiles that we would be placing. That's supposed to be tiles there, right? So we would need far fewer bits to do that, but you would still need to have 6 bits to do that. So you would only cut down on your map size by about 25% by using the larger tile size, but that's actually quite a bit. Then you could go up to a larger tile size and you could cut this down even more. Let's say you only had 16 tiles. You would only need 4 bits and you would cut your map size in half. Either way though, any of these arrangements, in reality, I think that storing all of these tile locations in maps is not an option if we want everything to be stored in memory, including the maps. Now, that said, with one aspect of the code, such as a map, being stored outside of that 48 kilobytes of memory, that might be a cheat I'm willing to do. So let's say you have a floppy disk with 1.44 megs. So you have a floppy disk with 1.44 megabytes of space on it. That's way more than our 48 kilobytes, right? And so to store some maps on that we would have to read in wouldn't be a big deal, because we could read that in very quickly and still generate the screen in time, even on older machines, that we could store our maps on there. So I think if we do maps, we will use them outside of that 48 kilobytes so that we can reserve the 48 kilobytes simply for our tiles and for our sprites. Okay, so in that way, it doesn't really matter what we do, and the 10 by 10 tile option I think is the most attractive, although it is hard to make 10 by 10 tiles look good. So we'll have to see what we do with that. And graphics are probably my weakest part. I do like to draw and do art, but I think that graphics are probably my weakest part here. So if anybody wants to make a bunch of 10 by 10 tiles and send them to me, that would be awesome. Okay. And I can get them into the right format, just the base binary data, which is what I want, because I can't have anything extra anyway. Now, so that's the tiles, and then we have the sprites. So how big are the sprites? The sprites that you were seeing there, that ship was 30 by 30. And so that's actually equal to 900 pixels, or divide that by 2, you get 450 bytes. And so then with 450 bytes. So with 450 bytes per sprite, I actually need double that, because I have a sprite and then I also have a mask in order to get the transparency. I want to make the sprites look decent. You don't want like a white or black box behind the sprite. It just doesn't look good. And so we need to place the sprite as well as a mask. Okay. And so that's 900 bytes per sprite. So if I'm using 8 kilobytes for tiles, 16 kilobytes minus 8 kilobytes is only 8 kilobytes remaining, which means that we can only fit about 8 of these sprites. So we'd have 8 sprites. Well, to me that's actually plenty, because we're going to have our protagonist sprite, and then we're going to have our enemy sprites, and you probably only need a few of those. So we might even be able to take some of these 8 sprites, not use them, and move that memory over to the tile set, so we have more room for things like building and so forth. So I think the 16 kilobytes is actually doable to have some decent gameplay. The main thing is that we're gonna, with that small tile size, to be able to have a good algorithm that arranges the tiles to look good, look natural, and also be not take up too much code, because I can't have it be too smart. I don't want to waste a ton of memory on code for the procedural generation of the maps as well. One other thing is it would be nice to have on your screen, as you saw the portals on the screen, and as you move to a portal and you move to the next screen, if you were to move back, so you move to this screen, if you were to move back to this screen, have it be the same only for the adjacent screen, because you're probably not going to remember, okay, if I go 3, 4, 5, 10 screens over, as I go back, I'm not going to remember what they looked like. But if you go back one screen, then you would see then the same environment. And so then you would have to store that. So if I was on this screen here and I wanted to move to another screen and go back, I would have to store the screen that I'm on, so that you went back, and possibly some of the surrounding screens, depending on how deep you want this to go. That would take memory as well, because you would have to kind of, as you're placing the tiles, you would have to store a map of those tiles, so you'd have kind of a grid that's, an array in memory that stored the map of those tiles as well. So it'd be interesting to see what I can actually fit in here. It's just kind of a fun exercise in conserving memory and seeing if you can still come out with a pretty cool game that has decent gameplay and looks okay. So that's the basic idea behind how I want to make the retro game fit in 48 kilobytes. I'm probably missing some glaring issues here. If you think of anything, leave it in the comments. If you have any ideas or anything you want to call out about what I've said, go ahead. I welcome any conversation. Thanks for watching, and I'll see you soon.